Welcome to this video on Ansys Fluent Workspace's Polyflow for blow molding with an emphasis on stretch blow molding. So the first step will be to read in a mesh and to update the units. So we can see the mesh here. We have a mold for a bottle. We have a rod, and then inside the rod mold is a preform. We'll use the use template to select blow molding and thermoforming. We have one fixed mold and one moving mold, and I'll update the duration to 1.05 seconds. Leave thermal off. Looking at general, confirm this is a 2D shell geometry. It's transient, and we'll leave the inertial effects on. Next step is to update the fluid. Look at density, we'll leave that. Update the viscosity to 1e to the 5th Pascal seconds. Then update the fluid zone, which is the preform. So I'll set the zones for the preform. Set an inflation pressure for a vacuum, 1e to the 6 pascals. And then for time dependency, I'll use an expression I've set up in a text file. So all I have to do is copy paste. Change from constant to expression. So that displays it. The next step would be the fixed mold. And the zone for that is just the plain mold. And the arrows, the darts are pointing towards the solid material of the mold, so it should be pointing outward like it is, so that's good. Next step is the moving mold. So update the zone to the rod. And in this case, the darts are pointing in the wrong direction, so I'll do a flip darts direction, and then I'll update the expression for the vertical velocity using another expression. And so that is in the Y direction. Next step is layers of fluid. So that would again be the freeform. In this case, we'll use a constant thickness of 5 millimeters. Update the fixed edges. And that will be the top edges, the top rim of the preform. So preform edge. Next step, contact with fixed mold. So select the fluid zone, which is the preform. And then the mold for the mold zone of contact. We'll just slightly adjust the penetration accuracy. Display that. Update contact with moving mold against the preform. And then mold of contact now will be the rod. And we'll update penetration accuracy again. This time, because the rod is touching the preform, we'll activate the allow contact release, and we'll put a pressure of 10 pascals. Display that. Next, we'll jump down to mesh deformations for the fluid. So we'll select the preform, which is the fluid. then we'll drop down here, condition 1 of adaptive meshing. So the preform mesh gets adapted. So select that zone. And then the contact mold would be the mold. And we'll update the minimum size, something a little bigger. Maximum size, something a little bigger. Tolerance, we'll set to 1,000th. And critical distance, make a little bigger. Display that. And then double check the adaptive meshing number of steps, make sure that's 5. We're on to the solution. We'll look at derived quantities, and we'll add in track vectors. And we'll select the ones that are parallel and perpendicular to D, the direction. And direction, we'll update to the vertical direction, which is 1010. And we'll enable the self-contact to get information if there are any warnings of contact, self-contact. Next step, looking at calculation activities, we'll update the convergence criterion to user specified, make a tighter convergence criterion. Then we'll update the transient controls, smaller initial time step, as well as the minimum. Maximum, make that smaller. And tighten up the tolerance. Next step, drop down the run calculation, do a check just to confirm everything is complete and valid. Click OK. Probably a good idea to write out a session here. And from there, go to calculate. So while it's running, we can go to transcript, see output as it's running, go to plots, you can see convergence history. So we'll let that run. Welcome back. Our simulation is completed. We'll just walk through generating some results. Go to the outline view, show results. Right click on contour. Here I'll pick the area stretch. And for surfaces, I'll pick the preform and do a display. So switch to graphics. So this is how it looks at the end. We can do an animation by taking the time step back down to 0 and then using play. And that concludes our video. Thank you for watching. Bye-bye.